Yeah, X-ray fluorescence technology enables an advanced separation of mixed heavy metals. Due to exposure to X-ray at a certain energy level, metals emit characteristic spectra, which enable their separation into, for example, copper, brass, and zinc. This effect can also be applied to concentrate valuable metals such as gold and silver. Bell sorters, such as the KSS XFL, are most suitable applied to the separation of heterogeneous materials with regard to their particle size and shape. Chute sorters operate with higher efficiencies when the properties of shape and particle size are more homogeneous. The next step is the separation of a copper product out of a heavy metal concentrate. Due to the coarse and wide size range, this material is processed on a bell sorter. An efficient material feed distribution is a key factor for a successful sort. The material in feed happens via a vibrating feeder that transports the material onto the belt and distributes the objects evenly in transport direction. As seen in the previous video, the material extraction is done by compressed air bursts. For the ejection, pressures of up to 10 bar can be used in order to remove even the heaviest objects. This could be, for example, large copper items. The copper product can exhibit purities of up to 99% and can be applied as feedstock in smelting facilities without additional processing. Along with copper, zinc and brass concentrates are common sorting products out of heavy metals. In addition to the detection of base metal alloys, X-ray fluorescence enables the recognition of surface coatings. One example are nickel or chrome-plated brass items used in bathroom appliances. These can be identified efficiently according to their specific surface characteristics. In the field of heavy metal sorting, the ChuTech allows an efficient sort starting at particle sizes of approximately 4 mm. The material is presented to the detection area and the extraction occurs after moving over a steep chute. The material is therefore not scanned while being positioned on a conveyor belt, but in flight after the chute. The distance between detection and material surface thereby remains constant, independent of particle size. Especially in the particle size range below 20 mm, the ChuTech has a strong advantage, due to the detection in flight and an advanced sensor resolution. The development of this system is a significant extension to our X-ray fluorescence portfolio. The addition of this processing line in the test center is most valuable in finding the most suitable solutions. The material shown here even has a size range of 3 to 15 mm. It is fed into the process using a magnetic vibrating feeder to create a constant and even flow. Ejection system in this case is also a valve bar. However, here the standard valve grid of 12.5 mm has been completed by adding a second grid with a spacing of 6.25 mm per valve to be even more flexible and efficient for the finest material. The result is a copper concentrate and a rest fraction which predominantly contains brass and zinc. These products can be separated in additional processing steps.